Okay, so we just watched a video, okay, on light. So it's a quick summary of what you have learned, isn't it? But now I'm going to ask you some questions. Okay, Grace is trying to come in. So let's let her enter first. Just 1 minute. Okay, she can't get in, so never mind. Let me see how I can help her get in later. Now, can you see my screen now? Today's worksheet is on light revision, worksheet 47. Okay, Grace is trying to get in. Okay, so can see my worksheet, right? So we just watched one of the videos. Later on, if we have time, we can watch a few more because I think you've already watched the video from Dr. Binox before. All right, so let's look at some of the pointers for light. Now, do you still remember? Do you still remember all these things that you've learned about light? Okay, what I have over here is light is a form of energy, right? Okay, and then it allows us to see things. Light is not matter because it does not have mass, does not occupy space. Okay, then we talk about properties of light. Light can travel in straight lines. Light can be reflected. What else do you recall? What else do you recall? Those of you who are here now, I want you to type into the chat just to let me know. What else do you recall? Mm-hmm. Okay, so Kalista says light does not occupy space. That's true. Okay, good. Just 1 minute. I think our dear friend is still trying to get in. While waiting, I want all of you to type in first, okay? You type in. Okay, give me 1 minute. Let me see how I can help Grace. Type into the chat, what do you know about light? Everything that you know about light. Okay, I'm back. All right, Grace, now you're in. Good. I saw you trying to get in just now. Okay, I think your camera is not working so well. Okay, I have responses coming in. Well done. So I see people typing in light cannot pass through opaque objects. So you saw this from the video just now, right? Light can pass through transparent objects fully, okay, and can pass through translucent objects partially. Wonderful. Jerome says, some objects are opaque, okay, some can be transparent, some translucent. Light is a form of energy. Light can be reflected. Okay, and then light travels in a straight line. Wow, something newer. Okay, sources of light actually gives off light. Very good. All right, so sources of light. Sources of light, you have two types. Do you all know that? Okay, one is actually natural, one is actually artificial. Do you all know about all this? If you do, you can type it in. Okay, so if you don't recall, quickly go and find out. Okay, what is one example of natural source of light? The sun. Yeah, very good. Okay. What about artificial source of light? Torch, light bulb, wonderful. Lamp. Good. Candle. Yeah, very good. Thank you so much for responding. That's good. Yang Kai, you need to turn on the camera. Yang Kai, Hui En as well. Okay, so we have talked about artificial, natural sources of light. Good. Then you have also shared something about light travels in straight line, then cannot pass through opaque objects, right? So when it doesn't pass through opaque objects, what is being formed? What will be formed? Shadows. Yes. So I see some of you actively responding. Well done. Okay, so shadows, things you need to learn about shadows. Remember, shadows can actually be very big, can be very small. So the size of the shadow depends on the following two factors. Okay, the following two factors. Number one, distance between object and the light source. Okay, then distance between object and the screen. Do you still recall? How many of you still remember all this from school? Okay, how do I make objects bigger? How do I make shadows of objects bigger? Phrase it wrongly just now. Okay, how do I make the shadows of objects bigger? We talk about the two factors already, right? So what do you think? What can you do if I want the shadow of a particular object to look bigger? Yeah. What about the distances? So we have two factors, right? The distance between object and light source. Grace said, move the torch closer to the object. Okay, that's what Grace said. What else? What else can you do? Other than moving the torch closer to the object, is there any other way? Or that is the only way only? We have no other ways of making the shadow bigger. Okay, Jerome says, move the screen further from the object. Yeah, okay, Grace said the same thing. Okay, so let's take a look. So distance between object and the light source. So if the distance between object and the light source decreases, all right, the shadow will actually increase in terms of size. Very good. Okay, so as the distance between object and the light source increases, of course, the opposite will happen. The size of the shadow will decrease. Okay, so that's one way. Hi, Yankai, I can see you now. Next, okay, distance between object and the screen. Okay, as the distance between object and screen increases, the size of the shadow increases. Then, if you have the distance between object and screen decreasing, the size of the shadow will decrease also. So this is pretty obvious. Okay, now, so let's look at our questions. I have your answers here with me as well. So later on, I'll be showing you your answer, okay, as we go along, running through these questions and answers. Okay, study the setup here. There's a retort stand. Retort stand is something that helps you to hold on to your gadgets in the science lab. So you will handle a lot of the retort stand as you move on to secondary school. Okay, and you might be even doing the experiment on your own. So you set up the whole thing yourself. Okay, nowadays it's just like the teacher set up for you, right? Okay, and then you just work in groups with your friends. Okay, handling a set of the apparatus and the equipment in the science lab. But when you go to secondary school, you're supposed to collect your own equipment, bring the equipment to your table, set up the experiment yourself. Okay, so that's what's going to happen when you go to secondary school. Very exciting. Okay, now, so there's a retort stand, and then there is this torch, right? That's attached to the retort stand. Okay, and there is an angle. So if you can see what they are trying to show here. Okay, so this is an angle where the torch is placed. It's not horizontal. So if this is the retort stand, and then I have the torch, it's bent downwards. Okay, so can you see that it's actually bent downwards this way, right? And then when the torch is turned on, is switched on, okay, the light will be shining on the object. Okay, so take note, there's a distance between the object and the retort stand also. Now, the following table consists of the results of the experiment. Distance of object from the torch. Okay, so distance of object from the torch, then they actually put this as the distance from the torch. Okay, so the length of the shadow cast on the table, all right, so you have 6 cm, 10 cm, and 19 cm, following the various distance indicated. What do you think is the aim of this experiment? Okay, aim of experiment. Okay, so the answer here, to determine how the distance between the object and the torch influences the length of shadow that's cast on the table. Let's see how you have written this. If I show you your answer, those of you who have tried, okay? So I can see Callista tried already, right? Then Jerome also, Myra, Grace, Zoe. Yours is partially done only. Right, not Zoe? Is that right? You only do some parts of it. You didn't complete the whole thing? Correct, how come? You know why I'm asking you, Zoe? Because I have students who actually did it the second time, right? The first time finished every single question. Then the second time wanted to relook at the question but didn't attempt the answers. Okay, so it turned out the student is classified as, having a lot of blanks everywhere. Okay, that means this is like the second try that's being captured. But you didn't, right? Honestly, you haven't tried the worksheet. Okay, must try. Right, maybe this is the holiday period, so you're a little bit relaxed, is it? Okay. I'm not scolding you, so please don't misunderstand that I'm scolding Zoe. I just want to be, I just want to play my role as a teacher, just to check whether you've done your work. Can? Now, if you can see your friends' answers. Okay, Callista, the aim of experiment to find out if the distance of object from torch affects the length of shadow cast on the table. Very good. Okay, so when I highlight, that means I've gotten it correct. Jerome, to see if the higher the number of distance, we don't say the higher the number. Okay, when you say the higher the number, it seems like can count, right? Right not? Okay, but the distance we measure is not like something that is counting one piece by one piece, right? Right now, Jerome? So be careful of that to see if the greater the distance, to see how the distance, I mean, the way you're phrasing it, makes it very difficult to mark. Okay, to mark this piece of work. Because you see, you don't just talk about higher or greater distance. It can be even smaller distances, shorter distances. Am I right, Jerome? So when you write down the aim, don't put yourself in this kind of situation where you're pointing towards a certain direction only. Okay, you just want to see how one factor affects the other. Okay, so you need to identify very clearly, okay, what is the variable? The variable is actually, especially the change variable. Here is the distances, right? Everything else is the same. Okay, so your change variable is put in. Then after that, what is it that we measure? What's the measured variable? It's actually the length of the shadow. So the length of the shadow is another area that you need to look into when you write aim. So even though you have the distance, okay, distance from an object, but you didn't mention is distance of object from torch. You didn't write down from torch. Okay, so that is also being marked down, Jerome. Be very careful. Can? Myra, to see the length of shadow cast on the table when the distance of the object from the torch is changed. Let me see. To see the length of shadow. Now, when you write aim of experiment, it is not written in this manner. Aim of experiment is always for us to find out something. Okay, it always starts with to find out. How many of you not very clear of how to write aim? Put out your hand. Do you all know how to write aim of experiment? So usually when you talk about aim, right, your teacher say before, you always start with to find out. Okay, and you need to identify the change variable, right? And then also the measured variable. So the change variable over here is actually the distance of object from the torch. We started off 10 cm.